I am back on my robot project. In this video, I will give you some background for the implementation of the robot kinematics in Linux CNC. I will show you which kinematics model I have chosen, explain which parameters have to be set, and which limits must be considered. We will look at how to write the VSMAC application for the 3D simulation, set up Linux CNC, and test the whole thing. Let's go! I prefer to start with an example. We are lucky and find an application in the current version of Linux CNC that is very similar to ours. Under Configs, Sim, Axis, VSMAC, 3-axis tutorials, Puma, we find a machine with 6 degrees of freedom. The link to the kinematics model and the 3D simulation are of interest to us here. We will look at these two applications in detail. Genseken stands for generic serial kinematics. If we jump into the function, we see that it is an iterative solution procedure for inverse kinematics. It should be noted that iterative methods do not always lead to a solution, especially in the region of singularities. Errors may occur and special actions may be required. I accept this because I have the highest possible flexibility with this variant. For the actual implementation, we now only need to determine the DH parameters of our robot. DH stands for Denevit-Hartenberg, and there are many good explanations available online that show how the convention works. In any case, I recommend creating a good sketch. It is also helpful to have the robot already in a useful, basic position. Once the sketch has been created, we need to assign the parameters to the corresponding HAL pins. However, we will start with a clean copy of the example machine. I always rename the files so that I can also find hidden links. Once this is implemented, you should find a structure like this one. A separate HAL file is provided for entering the DH parameters. This must of course be referenced in the HAL section of the INI. With these simple steps, we should have a working forward and inverse kinematics. You have probably noticed that the renaming of the files has broken even more links. We are trying to correct these with a simple replace command. This will certainly still give errors. I immediately notice that we can leave the machine type at Puma 560. While we're at it, let's change the unit of measurement to millimeters. We also see in the INI that some other references are still missing, but with a few copy-paste commands we should have everything together. We have now done the boring part. Now we can prepare the 3D simulation. First things first, we switch to a CAD program of our choice and generate STL files. It makes sense to simplify the robot model a little. Joining the joints will be easier if the joint axis is at a simple numerical distance from the outer edge of the model. I save the files in the same folder in which the machine INI is located. Before we start adapting the Python program for VSMAC, let's create a good sketch again. The rotations and translations of the parts always refer to an outer corner of the model. The procedure is always the same. The new joint is positioned so that it fits onto the previous one. The joints are then connected. As soon as they are connected, the assembly must be positioned so that the axis of rotation is in the center of space. The simulation program must be located in a folder that is listed in the environment path. The easiest way is to copy the Puma 560 GUI to the same folder and rename it. It is then already executable. It is important that the new paths for the 3D files are adjusted correctly. By the way, I have changed the document type to STL here. The Puma simulation is in inches, so it makes sense to adjust the graphic resolution. It is also helpful if you insert some reference surfaces to be able to position the axis better. Step by step, we can put all the joints together until the complete model is assembled. As soon as the simulation program is adapted, we can start Linux CNC and start a test NC code. At the first start, often a few references have to be added. However, the error messages are very good and require no further description. Finally, thanks for your attention and see you next time.